Hi Year 11, we're just going to go through this exam question from a recent mock. So it's a 5-marker and the question asks you to explain why a multicellular organism cannot absorb all the nutrients it needs by diffusion through its outer surface. So what the question is actually about is surface area to volume ratio. It was clear that some of you didn't understand this and some of you I think got put off by the maths because of the numbers the exam board had chosen, but you shouldn't let that put you off. You can do these ones, okay? Right, so what you had to do to get the marks is you had to compare the surface area to volume ratio for these two organisms, this tiny little bacterial cell and this bigger multicellular organism. So it's obvious that the smaller organism would have a smaller surface area and a smaller volume, so smaller skin and smaller amount of meat inside it, if you want to think of it like that. This one would obviously have bigger of both of those, but what we need to do is compare how much skin there is per unit of volume of meat inside, and that will give us a better idea of how these organisms actually interact with their environment. So this small organism, to work out its surface area, it is like a dice, so it has 6 sides. We need to work out the area of one of the faces, then multiply that by 6. So we do this dimension here, times by itself for the area of one face, times that by 6, and that comes out as this number here, so 2.4 times 10 to the minus 7, okay? And the surface area for the larger organism, 11 times 11, area of one face, times by 6, 726 centimetres squared. To work out the volume of each, you have to do all the dimensions, so height times width times depth, so 0.2 cubed gives us 8 times 10 to the minus 12, tiny little number. The volume of the larger organism, 11 times 11 times 11, 1,331 centimetres cubed. We then divide the surface area by the volume for each of them, so we get 0.55 parts of surface area to each one part of volume. Okay, so every centimetre cubed of volume of meat has less than 1 centimetre squared of surface area associated with it in this big organism. And that makes sense. If you picture that divided up into the 11 sections, I know that's not 11, some in the middle of here have absolutely no surface area. This one at the corner only has 3 sides that face outside. It has 3 that go back into the organism. So it's not going to be a big number of parts of surface area to volume, okay, for that reason. This one here, 1 part of surface area for that 1 unit of volume. Only one side of the meat faces outwards, okay? This teeny tiny organism, when you do its surface area divided by its volume, comes out as 300,000 to 1. So it has a huge amount of surface area for each bit of volume it's got, obviously because it hasn't got very much volume at all. It's a tiny little organism. So this one has got a vast surface area to volume ratio, absolutely massive. It can absorb all the oxygen it needs through that surface, whereas this one does not have a big enough surface area for diffusion to occur through, so the middle of this organism would die waiting for oxygen to diffuse in so it could use it for aerobic respiration. So the marks on the mark scheme are for calculating the surface area to volume ratio for both organisms, therefore working out the conversion of those to the same scale, so to get them both for how much surface area they've got per unit volume, okay? Then for explaining what this means, so diffusion distance is longer in the multicellular organism, okay? It's got a bigger distance to get into the middle of it. The volume supplied by each unit of surface area is greater in the multicellular organism, so each little bit of surface area has more volume to try and supply things to, all that meat that's hidden inside the organism, okay? So the rate of diffusion per unit volume is slower in a multicellular organism. So what you need to say on questions like this is that smaller organisms have larger surface area to volume ratios, larger organisms have smaller surface area to volume ratios, and if you have a small surface area to volume ratio, you cannot exchange things very quickly through your surface, whether that be heat or oxygen or waste products like carbon dioxide. Therefore, you have to rely upon exchange surfaces like lungs, gills, etc. to help you do that. Okay, I hope that helps. Take care.